Hello friends, myself Ajay Eknath Chaudhary and I have completed my BE in Mechanical Engineering. Today's date is 28th March 2022 and today is the original video for a topic garbage collection in Java. So JVM garbage collection, implementations and additional we will all find out how it enables a particular types of garbage collection in our application. In a brief introduction about the garbage collector, from the name, it looks like a garbage collection deals with the finding and deleting the garbage from the memory. However, in reality, garbage collection tracks each and every object available in the JVM heap space and removes unused ones. Uh, in simple word, in simple word, garbage collector works into two simple steps known as mark and swap. Advantages of garbage collection are no manual memory allocation or deallocation handling because unused memory space is automatically handled by garbage collector. No overhead of handling pointers. Automatic memory leak management. Next one, and disadvantages of it is that since JVM has to keep track of object reference creation or deletion, this activity requires more than CPU power than original application. It may affect the performance of the request which required for a large memory. Programmers have to control over the scheduling of CPU time dedicates to freeing object that no longer needed using some GC implementations. And next is of this type of implementation. JVM has five types of garbage collection implementation. That is serial garbage collectors, parallel garbage collector, CMS garbage collector, and G1 garbage collector, and Z garbage collector. First one we have to see about the serial garbage collector. This is the type of simplest garbage collector implementation, as it basically works with the single thread. As a result, this garbage collector implements freezes all the application thread when it runs. Hence, it is not a good idea to use it in multi-threading operations like server environments. And however, was an excellent talk by Twitter engineer on QCOM in 2012 on the performance of serial garbage collector, which is good way to understand this garbage collector better. The serial garbage collector is the garbage collector of the choice for the most application that do not have small pause time requirement and run on client style machines. Next is parallel garbage collector. It is a default garbage collector of JVM and sometimes called throughput collector. Unlikely serial garbage collector, this uses multiple thread for the managing heap space, but it also freezes other application threads while performing CG. If we use this GC, we will specify maximum garbage collection thread and pause time throughout throughput and footprint. The number of garbage collector threads can be controlled with the command line option XX semicolon parallel IGC thread. The maximum pause time goal uh, is specified with the command line option XX max GC pause millions is equal to generics n. The maximum heap footprints are performing the which is used for specified using for the option XMX generics n, where CMS third one is CMS garbage collector. The congruent mark swap, that is CMS, implements uses multiple garbage collector threads for garbage collection. It's designed for application that prefer shorter garbage collector pauses and that can be afford the share processor resources with garbage collector while application is running. Simply we put an application using this type of GC. GC responds slower on the average, but do not stop responding to perform garbage collection. Next is G1 garbage collector, where G1 garbage collector is designed for the application running on multi-purpose processor machines with large memory space. It's available since JDK 7 update and it later releases. G1 garbage collector will replace the CMS collector since its performance efficient. Unlike other collectors, the G1 garbage collector is stored in the heap into the set of equal size heap region, and each continuous range of the virtual memory. Next is Z garbage collector, where it is scalable low latency garbage collector, which debuted in the Java 11 has an experimental option for Linux. This introduced in JDK 14 under the Windows and OS operating system. ZGC has obtained the production status from Java 15 onwards. ZGC performs all the expensive works concurrently without stopping the execution of applications thread for more than 10 ms, which makes it suitable for applications that require for it. It uses load barriers with the colored pointer to perform concurrent operation when the thread are running, and they are used to keep track of heap usage. Now, as we've seen about the today's topic, that garbage collector is one of these memory management, where it takes only the efficient useful memory, and useful memory such as data types, useful data types and useful variables, and the variable which is not in use or we have created but is not in use, or data types we have created but not in use, it can be removed automatically, and it keeps the useful data on it. So it is very useful in Java. Without garbage collector, we cannot provide Java has a best application. So garbage collector is one of the main sources of Java. So thank you for watching my video.